So I've gone ahead and organized the chalkboard a bit so we can talk a little bit easier. What is going to be the goal? The goal is going to be to come up with a loop invariant, to then derive the state of the variables before the update and after the update, the step 6 and step 7, and that then will tell us how to do the update itself in step 8, and then we'll see what happens when we get to that point in terms of how the blocked algorithm and the matrix multiply comes in. Okay, so here we go. All right, first of all, this is the partitioned matrix expression. I've merely moved it from where we had it to up here. Well, what loop invariant should we pick? I'm going to pick the simplest one. I'm going to let you do the harder ones. All right, so we'll take away this and that and this. And that's our loop invariant now. Okay? Now, we can say, what should the loop guard be? Well, by now you're familiar enough to know that this is going to expand, so the loop guard is going to have something to do with the top left of A having the same size as A. And then what's the initialization step? Well, the initialization step is to say that A top left is empty. Those kinds of things hopefully by now are relatively familiar, and we'll end up with an algorithm that marches through matrix A from top left to bottom right and through B and C from top to bottom. Right? Those are all part of the steps that you're going to have to go through. So then we get to how do we repartition? Well, we repartition exposing now a block of C, a block of B, and a whole bunch of blocks of A. All right? Okay, so now that we have set the stage, let's go straight to step 6. What's step 6? Well, for step 6, we go and we take our loop invariant. We take how the different pieces are being redefined, we plug them in there, and off we go. So what do we get? C top is C0, C bottom is now C1, C2, and that's equal to A top left is A00, 0, B top is B0, and C top is C0 hat. And then C bottom hat is C1 hat, C2 hat. Okay? And that's step 6, and that's always relatively straightforward when the loop invariant is picked to be as simple as this. If we picked a different loop invariant, it would have become a little bit more difficult. All right, now what? Well, at the bottom of the loop, we redefine what C top, C bottom, etc. are. And how do we do that? We say, well, we move forward by moving this line from here to here. We take this and we redefine moving this line from here to here. And this is a little harder. We take this away and we take this away. And we move that from here to here. And now this expresses moving forward through the matrix. Okay, so then for step 7, what do we get? Well, this part is easy. And now, A top left is this 2 by 2 matrix of blocks. A00, A01, A10, A11. We'll come back to that. B0 is now, B top is now B0, B1, added to C0 hat, C1 hat. And the rest of this is just C2 hat now. Okay? Now, however, A is symmetric. When we expose these pieces, we realize that A00 is symmetric and A11 is symmetric. A10 is actually exposed, but A01 is not exposed. Well, let's go over here for a second. So why isn't that we just had, why didn't we just have A10 transpose sitting here, etc.? Well, that's because when we partition and repartition like this, we're really saying how are we going through the array that stores A. And the array that stores A still has these different pieces, and the array that stores A knows nothing about the fact that A is symmetric. It's only when we go over here and we try to compute with it that we need to remember. This actually is not stored, but we can compute with it by recognizing that we can compute with what is stored, namely that right there. All right? Good? And then all we do is we apply what we know about partitioned matrix multiply. This times that plus this times that. This times that plus this times that. So we know that this is just equal to, it's A00 B0 plus A10 transpose B1 plus C1 C0 hat. And then A10 B0 plus A11 B1 plus C1 hat. And finally C2 hat. All right, with the line right there. Okay, so that is what we get. And now what? Now we have to determine what the update must be. And what must it be? Well, let's figure out how C0 should be updated. So we recognize that it should be updated with A10 transpose times B1 added to what's already in C0. And then C1 should be updated with, well, it just has C1 hat, its original contents in it. It has to have this in it. So we say that should be equal to A10 times B0 plus A11 times B1 plus C1 hat. And that's our update. Right? And now you have your worksheet. You can go and erase everything that is just an assertion, and you end up with the actual algorithm. Okay? Okay, so why don't you think about this for a second, and then we're going to have another video with some more insights.